Hello everyone, welcome back to our channel TEQIP GATE classes. Myself Suraj Gupta, and here in TGC I am teaching currently mechanical vibration. Today we will discuss about the previous year questions. This is session number 2 and we have already done the session 1. Okay, so let us see what is the syllabus and what was the syllabus we have covered till now. So we have completed the complete syllabus of mechanical vibration. That was the theoretical portion, and we have parallelly solved some numerical problems and some conceptual problems, whatever they have asked in the previous year, or we have solved some question from the standard books. Okay, so as you can see that we have discussed all the topics from the mechanical vibration. Okay, so let us see what we are going to do today. Let me check how many of you are there. Okay, hello everyone. Okay, fine. So in the lecture plan we have done all the topics, as you can see, from lecture 1 to lecture 10, and especially in the lecture 10 we have discussed about the summary of numerical problem which has been asked in the which we have discussed in the previous lectures. Okay, so the complete numerical the complete formulas has been given in the lecture number 10. Okay, you can refer the lecture 10 to revise your numerical revise your formulas from each and every lectures. Okay, so this is very important for to do the numericals problem to solve. Okay, so today we do the same thing, the previous year question, as we have done in the PYQ 1, but the syllabus was undamped and damped vibration system. But today we will do for the force vibration and vibration isolation, and we will in the previous year from 2014 to 21 the critical speed shaft is missing, because so it is possible to the numerical problem from critical speed of shaft. It is very much possible that in the 2022 the numerical will be from critical speed of the shaft. Okay, so we will do in the PYQ 3 or numerical problem session in the next upcoming classes. Okay, so let us start with the review our formulas that we have discussed in the lecture 10 also. So there are several numerical point of view formulas and some theoretical point of view formulas is I have mentioned in the last lecture number 10. Okay, so many questions can be asked from these slides I'm showing you currently. For Newton's second law, D'Alembert principle is going to apply where, and how the total energy formula is going to be used for vibration equation to be find out. And then 7 is the equation of motion, how to create how to develop a equation of motion, and how to find out the displacement formula, displacement equation, or solution of the differential equation we have done. Okay, as at the same time we did, and we we make the analogy from the linear motion to the rotational motion by replacing some analogous, like for from mass it is converted into mass moment of inertia, and the acceleration is going to convert it into angular acceleration. At the same time the damping coefficient is converted into the torsional damping coefficient. Velocity is coming into what it is a angular velocity. Then stiffness, once again torsional stiffness, the displacement will come into angular displacement. At the same time the force is converted into the torque, but the sign function will be same. Okay, so we have discussed so many analogues, and we know that the C by M is known as the T zeta omega n, and K by M is known as the square of natural frequency. Okay, so these are the some analogies we have discussed. And the longitudinal vibration, when a bar is subjected to a force and the force is not means a constant load, it is providing a vibration to the vertical bar in an axial direction. So the stiffness of this bar will be divided by L. A is the area, E is the Young's modulus, and L is the length. So K is the property of, K is the materialistic property as well as geometrical property. As we can see that there is an area, the dimensions are there, and E is the materialistic property. So it is depending upon the geometry as well as material, right? Ninth is the torsional vibration of a shaft. What is torsional vibration of shaft? When we twist a shaft about its axis, polar axis, by angle theta, and we leave that, if we remove that torque, then the shaft will vibrate with respect to its axial axis. Okay, in that case the stiffness will be torsional stiffness, that is Gj by L. Okay, this is Gj by L, where G is the shear modulus, J is the polar moment of inertia, and L is the length. Once again, this is also depending upon the geometry as well as material. Okay, the 10th is the compound pendulum. We have discussed how the compound pendulum means any random body can be says as we can say that it is a compound pendulum if it is having a point of rotation. This point of rotation is also known as pivoted point, right? So this random body can vibrate also. It will have a natural frequency of mgd divided by I naught. I naught is m k naught square, but k naught is also radius of gyration, but it is to be find out. Okay, but we already we have to understand, we have to remember the moment of inertia of any object with respect to its center of mass or center of gravity, that is capital G. After that, knowing the value of moment of inertia about its center of mass, then we can find out the moment of inertia about its pivoted point or axis of rotation by applying parallel axis theorem. Okay, we have done that for, and we have seen the special case for compound pendulum, that is simple pendulum. In that case, what is the value of d? D is the length between pivoted point to the center of mass. So in the case of simple pendulum, this length will become L, the length of the string on which the simple pendulum is, the bob is connected, okay, with point of rotation, right? So in that case, the formula will become root of G by L, right? Then we can we have once again we have discussed about the equation of motion for forced vibration. Okay, so in that case, the zeta, we have find out that damping ratio zeta should be greater than 1 for over damped system which is not a vibration. Okay, equals to 1, that is critically damped, which is also once again not a vibration. Less than 1 is under damped system, which is a vibration for a certain period of time. After some period of time, its amplitude will become 0. So in the after it becomes 0, there will not be any vibration, but before that it is a vibrating, but decrease with a decreasing magnitude of the displacement, right? Means amplitudes. So we can see that the amplitude is continuously decreasing, x0, x1, x2, x3. So x0 is greater than x1, x1 is greater than x2, x2 is greater than x2, and so on, right? So in that case, we have find out what is the value of damped frequency, which is root of 1 minus zeta square omega, and logarithmic decrement we have find out delta equals to 2 pi zeta divided by root of 1 minus zeta square. Sorry, there was a mistake. You can correct it from the lecture 10 also. x0 divided by x1, we have find out that what is m? M is the start of m plus 1th cycle, and n is the start of nth cycle, right? Start of. So the formula for the ratio of amplitude, that will be exponential to the n minus m multiplied by delta. Delta is this one, right? So and then we have find out the characteristic curves for forced vibration, as well as we have find out the characteristic curve for the transmissibility, right? Transmissibility, we have find out transmissibility formula, and we have seen that in case of characteristic curve of forced vibration, the MF is always lesser if zeta is greater than, if zeta increases, MF will decreases always. Always for force vibration, that is MF. MF will always, sorry, the for any value of R. Okay, zeta is greater than 1. Sorry, zeta, if zeta is increasing, then magnification factor will decreases always. Always, you can see that everywhere. If we talk about the R equals to this value, then we can see that zeta is 0 here, zeta is 0 here, zeta is increasing, red to black, zeta is increasing, black to green, zeta is increasing. In that case, we can see that the MF is decreasing. Okay, MF is decreasing for any value of R, and it is any value of R, okay, from 0 to infinite, right? But in case of transmissibility, the characteristic curve is getting reversed after R equals to √2. Okay, zeta, when zeta is decreasing, then MF is increasing. But here, if zeta is increasing, then MF is also increasing. You can see that zeta is increasing in this direction. Zeta here is 0, here greater than 0, or we can say zeta here is 0 and here zeta is greater than 0, right? Okay, so zeta is increasing from red to blue, black, red to black. So we can say that zeta is increasing, so MF is also increasing, but after R is greater than √2, right? Is it correct? Am I correct? So this is very important formula, and from the formula we can draw the characteristic curve of the transmissibility, and we can understand the relation between zeta, MF and R, right? Then we have derived the equation for critical speed of the shaft, and we find out that the displacement of the maximum displacement of the shaft is eccentricity divided by 1 upon R square. Okay, 1 upon R square minus 1. What is R? R is the frequency ratio, and frequency ratio is omega divided by omega n. Omega is the disturbing frequency. Okay, fine. So this is all about the formula and some concept behind how we derive the formula. Okay, this is all about that. Now we are going to start the numerical problems we are going to solve, which were asked in the previous years. So the first numerical is okay, so let us start. Be careful by when we are going to read the question. Okay, and whenever we are going to see the options, you have to very careful. Okay, these questions are very simple, right? These questions are very simple, but sometimes these are the tricky, so we have to be very careful. और मैं आपको बता दूं कि जब भी हम न्यूमेरिकल को सॉल्व करेंगे, हम हर एक न्यूमेरिकल से कुछ ना कुछ सीखेंगे. मतलब ऐसा नहीं कि ये न्यूमेरिकल सॉल्व कर दिया और हम जीत गए, ऐसा नहीं करना है. हमको ये याद करना है कि न्यूमेरिकल हमने कैसे सॉल्व किया है, और मुझे एकदम याद हो जाना चाहिए कि मैंने इस टाइप के न्यूमेरिकल किस लेक्चर में देखे थे या फिर किस टॉपिक में देखे थे. ये आपको एकदम से रट जाना चाहिए. ओके, तभी आपको लगेगा कि हमने तैयारी बहुत अच्छे से की है, right? So each and every question, mostly the 1 marks questions are type of standards. Okay, कि ये स्टैंडर्ड है, आपको याद करना है, इस तरह के स्टैंडर्ड याद करने हैं आपको. तो हर एक क्वेश्चन से आपको सीखेंगे, मतलब ये आपका नोट्स का ही पार्ट है. ऐसा नहीं कि न्यूमेरिकल है अलग है. आपको ये सब न्यूमेरिकल पहले से पूछे जा चुके हैं, तो आपको इस न्यूमेरिकल से कुछ सीखना है. यू आर गोइंग टू लर्न समथिंग फ्रॉम these न्यूमेरिकल्स, right? Okay, so we will do the numerical problem very easily and very slowly to understand the concept behind the numericals. So the concept must be remembered. आप न्यूमेरिकल भूल जाओ कि न्यूमेरिकल मैंने ये वाला किया था, बट कॉन्सेप्ट मस्ट बी रिमेंबर कि कौन सा कॉन्सेप्ट मैंने अप्लाई किया हुआ है, ये कॉन्सेप्ट मैंने कहीं ना कहीं अप्लाई किया हुआ है, दैट यू हैव टू रिमेंबर. ओके, so let us start that in vibration isolation which one of the statement is not correct. So you have to be careful that not is given, not correct. Regarding transmissibility, transmissibility is, they are denoting by capital T, but we know that we can denote it by epsilon. Okay, from our so answer is B. A student is saying like Ajay Lakshya Chaturvedi, saying answer is B. B is correct. Good. So let us discuss. If you have time, just put your explanation also in the comment section. In vibration isolation, which one of the statement is not correct regarding the transmissibility? Okay, epsilon is nearly unity at a small excitation frequency. So just I am going to draw very fastly the transmissibility characteristic curve. Okay, at root 2. Okay, so as we can see that at it will become infinite when zeta is 0. When zeta is 0, then it is going at infinite when r equals to 1, and this is r equals to root 2, it will become 1. Okay, at r equals to 0, it is once again 1. So the option is T is nearly unity at a small excitation frequency. T is unity, correct, at very small excitation frequency. R is omega divided by omega n. So omega is excitation frequency. When it is very small, then R can be treated as it is equals to 0, right? So R equals to 0, it is unity. So option A is correct, right? Option B is T can be always reduced by using higher damping at any excitation frequency. Okay, so we any excitation frequency reduced by using higher damping. Higher damping means increasing the value of zeta. Higher damping, what is the meaning of that? Increasing the zeta value. So when we increasing the zeta value, the curve is going like this. Okay, so we have discussed in the summary of formulas that zeta is the transmissibility is when the transmissibility increases in this direction, the MF is decreases. But in this case, when zeta is increasing, the MF is also increasing, right? So it is not like that. Transmissibility is increasing when zeta is increasing when R is greater than root 2. Okay, so here in the R is greater than root 2, then zeta is increasing, then MF is also increasing. But when R is less than root 2, when zeta is increasing, MF is decreasing, right? So but they are saying in option B that this transmissibility can be always reduced, they are saying, but it is not correct. Okay, so the option B is incorrect. Let's see this option C. The transmissibility is unity at frequency ratio of root 2. Unity at root 2, the transmissibility is 1, right? So option C is also correct. Option D is T is infinity at resonance for undamped system. Undamped means zeta equals to 0. Okay, am I correct? Zeta is 0. At zeta equals to 0, what is the transmissibility at R equals to 1? What is the meaning of R equals to 1? What is the meaning of R equals to 1? What is the meaning of R equals to 1? R equals to 1 means resonance. R equals to 1 means resonance. Okay, at resonance, the transmissibility is infinite, right? So option D is also correct. So the incorrect option is B. So the answer is B, right? Good. Second question. Second, this is 2 marks question. This was asked in the 2015 set number 1. Once again, we will learn something from this numerical also. So up and you can see that this question is like it is net numerical answer type question. Numerical answer type question. So in this type of question, you have to understand, you have to be careful by checking the unit of which they are asking. Okay, because you are not going to enter, you are not going to type the numerical value with unit. Okay, so you have to check the last line, mostly the last line in which unit they are asking. Okay, so your answer must be in that unit, right? आंसर निकाल के बहुत खुश नहीं हो जाना है, तुरंत वो आंसर पुट करके आप आंसर दे दोगे, वो गलत हो जाएगा, आपको लगेगा आंसर सही है और आंसर सही भी होगा, बट आपने आंसर दिया नहीं सही से, राइट? आंसर आपने सॉल्व भी कर दिया, सारा सॉल्यूशन भी सही निकाला आपने, आंसर भी सही है, बट यूनिट नहीं चेक किया और आपने आंसर दे दिया, तो वो आंसर देना गलत हो गया. उसने पूछा न्यूटन पर मीटर में, आपने दे दिया न्यूटन पर mm में, तो आंसर गलत हो जाएगा. सो यू हैव टू बी वेरी केयरफुल फॉर नेट टाइप ऑफ क्वेश्चन, दैट you have to understand what unit they are asking. Okay, a precision instrument package m equals to 1 kg needs to be mounted on a surface vibrating at 60 hertz. Okay, they are showing this frequency in hertz, means linear frequency is given. Okay, and this is vibrating, means this is the excitation frequency. They are not talking about any natural frequency. So the mass is given, m is 1 kg, frequency is 60 hertz. Okay, if we talk about the angular frequency, it will become 2 pi f, right? So 2 pi multiplied by f is 60, so it is 120 pi, right? Then it is desired that only 5% of the base surface vibration amplitude be transmitted to the instrument. Okay, means how much transmitted force is there, means Ft divided by F naught is given, means epsilon is given, that is 5%, right? What is the meaning of 5%? It is 0.05, right? Ft divided by F naught is given, that is epsilon, which is 5%. ट्रांसमिट कितना हो रहा है? सिर्फ 5% हो रहा है. किसका? F naught का 5%. Okay, assuming that the isolation is designed with the natural frequency significantly lesser than 60 hertz. Lesser than 60 hertz. What is the meaning of that? Omega n should be less than 60 hertz. Sorry, not omega n, it is Fn, natural frequency, but it is linear. It is linear. Fn should be less than 60 hertz, so that the effect of damping may be ignored. Effect of damping may be ignored. Okay, the stiffness to be find out. The stiffness of the required mounting pad is. Okay, the stiffness is they are asking for in Newton per meter. Okay, so how we are going to solve, how to start this question? By using the formula of which formula we are going to talk about? Which formula we are going to use? Kindly comment which formula we are going to use. They are asking for the stiffness. Stiffness will come out from this formula, because we know that if we going to find out the value of omega n, it will be less than 60. So omega n will be less than 2 pi multiplied by 60, means 120 pi. It should be less than 120 pi. Okay, so we are going to use the formula that is Z epsilon. Epsilon is the formula of root of 1 plus 2 zeta r whole square divided by root of 1 minus r square whole square plus 2 zeta r whole square, right? Right. But they are asking that assuming that the isolation is designed with the natural frequency significantly so that the effect of damping may be ignored. Effect of damping may be ignored. What is the meaning of that? May be ignored. What is the meaning of that? Its meaning is zeta is 0. Damping is 0. So the epsilon, the formula for epsilon will become 1 upon 1 minus r square whole square, but in the root. When we replace this root, then the value will become like 1 upon 1 minus r square, but with plus minus sign. Okay, plus minus sign. Fine. Then plus minus 1 minus r square equals to 1 upon epsilon. What is the value of epsilon? It is 0.05. 0.05. 0.05. 1 upon 0.05. I think some students will get confused that why we are writing like plus minus. I am going to show you. If we talk about plus 25, sorry, what is the square of this plus 5? It is also 25. What is the square of minus 5? It is also 25. That's why we can take plus minus sign. Okay. Good, very good. Answer is correct. 6767.60. Very good. Okay. So this plus minus 1 minus r square equals to what is 1 upon 0? It will become 20. Right? It will become 20. So which sign we will take for real value of r? Which sign we must take? For the real value of r, we have to use negative sign, right? For the real value of r. So it will become 1 minus r square equals to 20 for real value of r, the frequency ratio. Okay. So this will become r square minus 1 equals to 20. So r equals to r will be root of 21. What is the value of root of 21? What is the value of root of 21? अजय लक्ष्य बताओ रूट ऑफ 21 की वैल्यू क्या आएगी? क्या आ चुकी है तुम्हारी? 4.58 4.58 and we know that r equals to root of, sorry, it is omega divided by omega n. Okay, omega n. And what is the value of omega n? Sorry, omega is omega is 120 pi divided by root of k by m. What is the value of m? M is 1 kg. 1 kg. Okay. So from this you can find out that k equals to 6767.60 Newton per meter. Okay. This value you have to type when you are going to give the exam, take the exam GATE. Okay, so you have to write only 6767.60. not the unit. You are not able to write the unit. Okay. So this is the answer, 6761.60 Newton per meter. Fine. Next. So I think it is very clear to all. Next. Problem number 3. A single degree of freedom spring mass system is subjected to sinusoidal force of 10 Newton amplitude and frequency omega along the axis of the spring. Okay. The stiffness means the force is like F equals to 10 sine omega t. Okay. Omega is given. Omega is not, the value is not given. And the notation it is given omega. Okay. The stiffness of the spring is K is 150 Newton per meter. Damping factor. Damping factor is also known as damping ratio. So zeta is given, that is 0.2. Under damped system hai ye. And the undamped natural frequency is, undamped means free natural frequency, free or undamped natural frequency is omega n, that is 10 omega it is given. Okay. At a steady state, the amplitude of the vibration is approximately, how much it will be? We will find it from the formula of, whenever we talk about the steady state amplitude, that is A. That will be comes from the magnification factor formula. Okay. A equals to F naught divided by K divided by root of 1 minus R square whole square plus 2 zeta R whole square. Okay. This is very simple question. Just directly you can use the formula of magnification factor and you can find out the value of A. A divided by F naught by K, this is the static. We can write delta static or we can write X static. Okay. This is F naught by K and each and every value is given. How? What is the value of R? R equals to omega divided by omega n, which is omega divided by 10 omega, means 1 upon 10, 0.1. 0.1 is given. Okay. So what is the answer? Answer is B. Very good. Answer is B. Let me check. Answer is okay. Your answer is coming 0 answer okay 0.07, right? 0.07. Let us check which answer is correct. A equals to F naught. What is the value of F naught? It is 10 divided by K. K is 150, right? 150 divided by root of 1 minus 0.1 square whole square plus 2 into 0.2 into 0.1 whole square. Okay. So let us find out the value of A. So 0.1 square 1 minus answer whole square plus 2 into 0.2 into 0.1. This is 0.1. Bracket close square. You can take the root of the whole answer and then multiply by 150 and then 10 divided by answer. It is, the answer is 0.067. So we can write 0.07 is the correct answer. Okay. So the answer is 0.067, right? अजय लक्ष्य बताओ, आंसर 0.067 आया था. Have you got the answer 0.067, not the exact 0.07? Am I right? It is in meter. Right? You must be getting the value 0.067 and from the option we can tick on answer B. Okay, after rounding it off. Right. So let us move to the next problem. This is also once again 2 marks question. Okay, तो जल्दी से आंसर बताइए इसका. क्वेश्चन नंबर 4, प्रॉब्लम नंबर 4. जल्दी से बताइए इसका आंसर क्या होगा. They are asking for ratio, so it will not have any unit. It will not have any unit. So what are the given datas? A single degree of freedom spring mass system is subjected to harmonic force of constant amplitude. Amplitude is a constant, its amplitude is constant for an excitation frequency. They are asking, they are giving the value of excitation frequency, that is omega. Omega is giving, they have given 3k by m. The ratio of the amplitude of the steady state response to the static deflection of the spring. Right? They are saying that amplitude of steady state response to the static deflection of the spring. What is the meaning of that? Steady state is given like capital A divided by static deflection, delta static, or we can write it as A upon capital X static. Okay, what is this ratio is called? What is the name of this ratio? Anyone? What is the name of this ratio? What is the name of this ratio? The name of this ratio is magnification factor. Okay, so formula for the magnification factor is 1 upon root of 1 minus r square whole square plus 2 zeta r whole square. And we can see that from the diagram that there is no damper. Damper is missing. Damper is not given. So zeta is 0. Zeta is 0. Right? Answer is correct. 0.5. Good. Very good. So I was asking for that. What is the ratio is known as? What is this ratio is known as? What is the name of this ratio? You can write your answer. So what is the what will be the formula for this MF will become? It will become A equals to sorry A they are asking for MF, right? A divided by X static MF. They are asking for MF. MF equals to 1 upon 1 minus R square. Okay, because zeta is 0. Zeta is 0, right? And this is plus minus. This will be plus minus. We will check whether it is the value is coming negative or positive. Then we will decide which we are going to use plus or minus. Okay. So what is the value of R? R we can find out. R we can find out that R equals to how much it will be? How much it will be? Omega divided by omega n. What is the value of omega? Omega is root 3k by m divided by root of k by m, because only k is given, only mass is given. So the system will have the natural frequency of root of k by m. Okay, so natural frequency is root of k by m, right? So the value of r will be root 3, right? Root 3. So what should be the value of the denominator? It will be positive or negative from this red signs, plus minus. We should take negative sign because the MF must be positive. MF must be positive. So the MF formula will become R square minus 1. Okay. So what is the value of R? R is root 3. So it will become R square. R square is 3. 3 minus 1. So the answer is 0.5. MF is 0.5. Okay. Fine. Very good. So the move towards the next problem. Next problem. This is 1 marks question, which is very simple. Why it is simple? Because you have remembered this formula. They are asking for the formula, the damping ratio. They are asking for the damping ratio formula. So this is also very simple question. They have asked in the 2017 1 marks question in set number 1. Okay, for this type of from this type of differential equation, this is the forced damped vibration system, right? For that, if this force is not also available, means if we this is not a forced vibration, this is just a damped free vibration, then also the zeta is defined, and zeta is c by 2 root of km. Okay, but from this equation we can write, we have to understand something else also. So and which is we have already discussed. If we divide the whole equation by mass, then the equation will become c by m x dot plus k by m equals to ft upon m, right? So what is the value of zeta? We can find out that c by m equals to c by m must be equals to 2 zeta omega n. Okay, and this k by m is omega n square. Okay, so you have to remember this formula also, which we have already discussed. Okay, so the answer is B, correct. C by 2 root of km. So from this formula, c by m equals to 2 zeta omega n, you can find out that the answer, the option B is correct. Okay. Next, this is once again 1 marks question. So you have to understand the unit or which type of frequency they are asking. Okay, it is they are asking for linear frequency, or they are asking for angular frequency. Okay, so which frequency they are asking? They are asking for net angular frequency. Okay, so there is no any 2 pi term will be coming. Okay, there will not be any 2 pi term will be coming. Which answer is correct? This is very simple. This is also on the basis of formula directly. The problem number, this was 5. This was 5. And this is 6. This is 6. So the this is undamped. Undamped means zeta is 0. Zeta is 0. They're asking for like yes. If we talk about magnification factor, they are not talking about any isolation. Okay, so we can understand that they are only asking for magnification factor or related to the magnification factor or the displacement of the system, right? So magnification factor we can draw for undamped force vibration. Undamped means zeta equals to 0. So we will have only one curve which is going to the infinite at r equals to 1, coming back from r equals to root 2 where mf is 1. Okay, this is r equals to 1 and this is r equals to root 2. So from this equation, what is the equation of this curve? It will be 1 upon root of 1 minus, 1 upon 1 minus r square, but it should be plus minus. Okay, depending upon the value of r, the formula can be changed. Okay, so for this, when r is less than 1, what should be the value of mf? What should be the value of mf? What should be the value of mf? We are going to fix this confusion. Okay, when r is less than 1, okay, r is less than 1 and r is increasing from 0 to 1, then mf is increasing. So the formula for this curve, this side curve, will be 1 upon r square minus 1. Is it correct? R square, if we increase the value of r from 0 to 1, and this is mod. Okay, mod value we have to take positive. If r is greater than, if r is increasing, okay, then mf is also increasing. Or we are writing wrongly. You can check out from this equation mf, if we increasing the r from 0 to 1, increasing the r, then r square will decrease once again. Okay, r square will decrease because 0. If we take the r equals to 0.1, then the 0.1 square will be 0.01. Okay, so 0.01, then this term will increase. This term will increase. So this whole term will decrease. This whole term will decrease. Right? This whole term will decrease, means mf will decrease in between 0 to 1. Okay, they are saying that it will be decrease. How? So this is not correct. This is correct for second curve. This is second curve. This is first curve. This is a complete one curve, but it is going to infinite and coming back from the infinite to the one value, and we can say towards the 0 value of mf. Okay. So this is this equation is correct for second. So we can write it that 1 upon r square minus 1 is correct for first curve, right? So ultimately we know that the resonance is occurring at r equals to 1. R equals to 1 means omega equals to omega n, right? Omega n is the value of the ratio of root ratio of stiffness upon mass. So answer is D. I know this answer is correct. Okay. So answer is D. Now the next question, question number 7. This is 2 marks question. 2 marks question. A machine of mass m 200 kg is supported on 2 mounts. Okay, 2 mounts means both are having a stiffness of K, and K is given, that is 10 kilonewton per meter. You have to be very careful that they are giving in kilonewton per meter. Okay, the machine is subjected to, so we are going to write the given data, m equals to 200 kg. So what is the stiffness, equivalent stiffness? It is 10,000 plus 10,000, because both are in parallel. So it is 220,000 Newton per meter. The machine is subjected to an external force. External force is having an amplitude of 50, that is F naught equals to 50. And what is the value of excitation frequency? What is the value of excitation frequency? Anyone, please? What is the value of excitation frequency? What is the value of excitation frequency? Excitation frequency is 5 because Ft is F naught sine omega t, and it is given the 50 sine 5t. Okay, so by comparing with, we can find out the values radian per second, and this is Newton, right? What are the other given datas? Nothing is given, assuming only vertical translatory motion, only this type of vibration is going on. So the magnitude of the dynamic force transmitted, okay, they are asking for the transmitting force to each mount. It's not they are asking for the complete transmitted force. They are asking for one transmission force will be coming from this stiffness, and from second it is Ft2. But ultimately both are same. Okay. So the total transmitted force is 2Ft. Okay. 2Ft divided by F naught by K. Okay. Sorry, it is not K. We are not going to find out the magnification factor. It is the transmissibility. They are talking about transmissibility. So the 2Ft, this is the total transmitted force. One is from the first spring, and second is from second spring. So the total is 2Ft. So the ratio is root of 1 minus r square. Sorry, what is the formula? 1 plus 2 zeta r whole square divided by 1 minus r square whole square plus 2 zeta r whole square. Once again, there is no damper, zeta is 0. Zeta is 0, zeta is 0. So the equation will become 1 upon mod of 1 minus r square. Okay, 1 upon 1 minus r square. Mod क्यों लिया है? Plus minus ये depending upon the what is the value of value should be in a real case. So we can change the sign, plus or minus you can take. There will be two values, but which value we are going to take on the basis of which value they are asking. Okay, each and every value in this formula are real. Real means they are not going to be imaginary. Imaginary means there is no any iota type of values, right? The answer is 66.67. No, वही मैं बोल रहा था कि गलतियां हो जाएंगी अगर आपने ध्यान से क्वेश्चन नहीं देखा. ओके, क्वेश्चन को लास्ट में ध्यान से नहीं पढ़ा. टोटल ट्रांसमिटेड फोर्स नहीं बताना है, हमें बताना है ईच माउंट में फोर्स कितना जाएगा. तो हमने तो आंसर निकाल लिया 66.66. हम खुश हो गए बहुत ज्यादा और आंसर लिख दिया खुशी में और आगे बढ़ गए. लेकिन हमने लास्ट वाला लाइन भूल गए. हम लोग की लास्ट में क्या पूछा था, एक माउंट में कितना होगा. तो 33.33 एक में होगा, दूसरे में कितना होगा 33.33. So the transmitted force in a single mount will be 33.33 Newton. Okay. So what is the value of R? R will be from this equation, from this given data, we can find out the value of natural frequency, root of K equivalent. K equivalent is 20,000 divided by mass. Mass is 200, right? Mass is 200. So 20,000 divided by 200, it is 100. Root of answer is 10. Okay, natural frequency is 10 radian per second. So R equals to omega divided by omega n. What is the value of omega? Omega is 5 divided by 10. So it is 0.5. Right? So 1 upon 1 minus 0.5, then it will give us a positive value. It is 0.5 square. 1 minus answer. 1 upon answer is 1.33. 1.33. So what will be the value of Ft? Ft will be 1.33 multiplied by F naught. F naught is 50. F naught is 50 divided by 2. Okay. Into 50. 1.33 multiplied by 50 divided by 2. So the answer is 33.33 Newton. The answer is not 66.6. It is 33.33. Right. So you have to check what they are asking. Okay. Every time you have to check what they are asking. Means your answer is correct, but you are not giving the answer correct. जो आंसर वो पूछा जा रहा है वो नहीं दे रहे हैं. आंसर आपका सही है, लास्ट तक सही है. ओके, तो आपको ये सब ध्यान में रखना है. ओके, सो we have discussed total 7 question, and this is last but not least. This is also very good question. 1 marks question, good question. So a single degree of freedom oscillator is subjected to harmonic excitation force, that is F naught sine cos omega t, as shown in the figure. The non-zero value of omega for which the amplitude of the force transmitted to the ground will be F naught. Okay, means what they are asking for. Once again we can draw. They are talking about transmission. So आपको क्लिक करना चाहिए तुरंत कि हमें फॉर्मूला यूज करना ही पड़ेगा ट्रांसमिसिबिलिटी का. ओके, so the formula is whatever the formula we can write, just 2 zeta r square, just to remember the formulas. 1 minus r square whole square plus 2 zeta r whole square. But in your mind you have the curve also with respect to r for the transmissibility. Okay, so what they are telling that the amplitude of the force transmitted to the ground will be F naught, means Ft is F naught. What is the meaning of that? Ft upon F naught equals to 1, means अपसाइलेन 1 कब होगा, मीन्स ट्रांसमिसिबिलिटी 1 कब होगी. ये कब होती है ये वैल्यू. बट देखिए कब होती है वैल्यू. कब होती है, ऐसे गया. बट देखिए अब जीटा 0 नहीं होगा क्योंकि सी गिवन है, तो इनफाइनाइट में नहीं जाएंगे हम, कहीं बीच में से जाएंगे. बट वो कहाँ से पास होती है, √2 से. ठीक है, यहाँ पे r इक्वल टू क्या है, √2. यहाँ पे r है 1, यहाँ पे है r 0. ओके, तो कौन सा आंसर सही है, कौन सा आंसर सही होगा. r 0 हो सकता है क्या? Is it possible that r equals to 0? R cannot be 0 because omega n never can be 0. Okay, omega 0 हो सकता है, but they have given that non-zero value of omega. Okay, so this value, the value of epsilon means transmissibility. We are not talking about r equals to 0. So what is the value of r where epsilon equals to 1? epsilon equals to 1. दो वैल्यू है हमारे पास, एक यहाँ पर है, एक यहाँ पर है, जहाँ पे epsilon की वैल्यू क्या है, 1 है. ओके, epsilon की वैल्यू कहाँ है, epsilon equals to 1 at r equals to 0 and r equals to √2. But this cannot be used as per the question. Okay, so r equals to root 2, and we know that r equals to omega upon omega n. What is omega n? It is k by m equals to root 2. So omega will be root 2 multiplied by k by m. Okay, so the answer is b. Very good. Answer is b. Okay, so this is all about the numerical problem from 2014 to 2021. Okay, so this is we have done for from where the question is, the GATE exam is conducting on computer based. Okay, so in the from 2014 the type of question and some pattern has been changed from 2014. So we have completed all the numericals from 2014. न्यूमेरिकल नहीं, सारे प्रॉब्लम्स 14 से लेके 21 तक के सारे क्वेश्चन हमने कर लिए हैं. ठीक है, अब हम 2014 से पहले भी जाएंगे. सो जितने इंपॉर्टेंट क्वेश्चन है, जो क्वेश्चन अभी भी रिपीट हो रहे हैं 14 के बाद भी, उन सारे क्वेश्चन को हम अभी फिर से रिवाइज करेंगे इन PYQ Session 3. Okay, in the next Sunday we will do that, the PYQ session. The Sunday, it can be Sunday or it can be Monday, means there are 3 slots, Saturday, Sunday or Monday. There will be possibility of when we are going to take. Okay, so it can be on Saturday, it can be on Sunday, or it can be on Monday, right? So I will inform you on our Telegram channel then when the next last session of numerical problem will be held. Okay, so till then, thank you all, and just follow us so that we can give our 100%, and you can also give your 100% in the exam. And best wishes to all. Thank you very much.